Yes, today we have derivative of parametric forms. Now, first of all, what are called parametric forms? When both the variables x and y, or you can say the dependent and independent variable, when both are expressed in terms of a single variable, we call the form as a parametric form. For example, in case of a parabola, this is the equation of a parabola. You have y square equal to 4ax. The form is y equal to 2at and x equal to at square. If you put these two numbers here, it will be verified. Y square will be 4a square t square and 4ax it will be 4a square t square. So this is the parametric form of a parabola, and you can see here y is expressed in terms of t and x is also expressed in terms of t. Similarly, in case of a circle, if you want to go for the parametric form, x equal to r cos t and y equal to r sin t, both are expressed in terms of t. So this is also called the parametric form. Means in this case you have both the variables expressed in terms of a other single variable. And now how to find a derivative? This is quite easy. Suppose for this very number y square equal to 4ax, you need to find dy upon dx. It will be dx upon dt divided by dx upon dt. First of all, go for dy upon dt. As in case of this parabola, dy upon dt will be 2a and dx upon dt will be equal to 2at. So if I divide the two numbers, this is 2a upon 2at, it will be 1 by t. And you can see I have verified the result in simple case also. You have y square equal to 4ax. If you simply differentiate, it will be 2y dy upon dx equal to 4a. That means dy upon dx will be equal to 4a upon 2y, that is 2a upon y, and if you put the value of y here, this is 2at, so it comes down to the same as 1 upon t, 1 upon t. That means there is no difference in finding the derivative of direct numbers or in the parametric form. The only thing is, it's not always easy that you eliminate this other variable t. As in this case, if you eliminate this t from t, you can find the value of t from here, y upon 2a, you put it over here, you got this curve. But in some of the tedious parametric forms, it becomes difficult. So it's better to go for this formula while finding the derivative. Let's go for the few examples. Yes, we have y equals to e raised to power t cos t and x is equal to e raised to power sin t. You need to find dy upon dx at the point say t equal to pi by 2. First of all, I go for dy upon dt. This is product of two functions. So product rule we will use here. This is cos t as it is, derivative of et is et, minus then et as it is, derivative of cos is minus sin. So this is e raised to power t common, cos minus sin, and similarly for dx upon dt, e raised to power t as it is, derivative of sin is cos, and sin as it is, derivative of et is et. So it is common, cos plus sin. Now use the formula dy upon dx is dy upon dt divided by dx upon dt. Place the values. This is dy upon dt and this is dx upon dt. So et will cancel down. It will be, you will be having cos minus sin upon cos plus sin. Divide both numbers by cos. 1 minus tan, 1 plus tan. That is tan of 45 minus theta minus t. Now you need the value or derivative at t equal to pi by 2. So put t equal to pi by 2 here. This very t. So pi by 4 minus pi by 2 minus pi by 4. This is minus 1. So this is a simple form. Let's go for two more examples. Yes. Now this is x equal to, you have a theta minus sin theta, y equal to b 1 plus cos theta. We need to find dy upon dx. Dx upon d theta. Yes, dx upon d theta will be a as it is. Theta is, derivative is 1, sin is cos. And for dy upon d theta, b as it 1 0, derivative 1 is 0, cos is minus sin. So let me divide dy upon dx is dy upon d theta divided by dx upon d theta. Put the values of dy upon d theta and dx upon d theta. Yes, I express sin theta as 2 sin theta by 2 cos theta by 2 and 1 minus cos is 2 sin square theta by 2. 2 will cancel down, so 1 sin will cancel down, it's minus b upon a into cot theta by 2. So this is the derivative. Let's go for a few more examples. Yes. Now this is x equal to a sin t, y equal to a cos t log tan t by 2. Yes, dy upon dt first, a as it is, cos is minus sin, log is 1 upon tan t by 2. tan का derivative is secant square and derivative of t by 2 is 1 by 2. So tan becomes cos by sine. The reciprocal of tan is the cos, that is cos by sine. Secant square is 1 upon cos square. 1 cos will cancel down. This is 2 sin t by 2 cos t by 2. That is sin t. So after LCM, this is 1 minus sin square upon sine. That is cos square by sine. So 1 cos by sine will be cot and 1 cos is as it is. Now for dx upon dt, it is a cos t. So after dividing dy upon dx, to find value of dy upon dx, after dividing dy by dt divided by dx by dt, this is a cos t will cancel down, it's only t. Yes, one more example is here. This is x equal to 1 plus log t by t square, y equal to 3 plus 2 log t by t. Now dy upon dt, go for the quotient rule here. This is new denominator square. Denominator as it is t, derivative of 3 plus 2 log t, derivative 3 is 0, 2 log t is 2 by t, minus numerator as it is, derivative of t is 1. So after calculation, this is minus 1 minus 2 log t by t square. Now for dx upon dt, again I use the quotient rule for this number. It will be t4, t square as it is, derivative of this is 1 0 and log t is 1 upon t, minus numerator as it is, derivative of t square is 2t. After calculation, this is what we have as this complete. This is dx upon dt. Now for dy upon dx, this is dy upon dt divided by dx upon dt. Placing the values of dy by dt and the value of dx by dt. After cancellation, it is t. And in this very problem, we have to show that y into dy upon dx minus 2x dy upon dx are equal to 1. So we need to place the values here. Now the value y was this 3 plus 2 log t by t, dy upon dx we have is simply t, minus twice the value of x from here into dy upon dx is t square. After calculation, the desired result will be here. Then next is derivative of function with respect to another function. Suppose you need to differentiate fx with respect to gx. In this case, what you have to do is, you suppose here, let say u equal to fx, and similarly you suppose that v equal to another function we have is gx. Let it be gx. Now you need to find derivative of fs with respect to gx. That means you are looking for du by dv, and this is given by, or you can say derivative of fx upon gx, derivative of fx with respect to x, and derivative of gx with respect to x. Few examples for that. Yes, in this case we need to differentiate tan x with respect to cos x. I suppose u as tan x, v as cos x. You are looking for du upon dv, that is du upon dx divided by dv upon dx. Derivative of u is tan secant square, v is cos is minus sine. So this is what we have the required derivative. Yes, one more example here. We need to differentiate this number tan inverse root 1 plus x square minus 1 upon x with respect to sine inverse of 2x upon 1 plus x square. Now as we remember, in case of a square plus x square, we need to put x equal to a tan theta. So a being 1 here, I put x equal to tan theta. Means first of all, I am simplifying this number before doing the derivative. Similarly, I'll go for simplification of this also, because this is possible. So I put x equal to tan theta. This is 1 plus tan square minus 1 upon tan. That is secant square minus 1 upon tan. Now what secant square is? 1 upon cos. Tan is sine upon cos. LCM will cancel down. 1 minus cos upon sine. And 1 minus cos you have is 2 sine square t by 2. And sine you have is 2 sine t by 2 cos t by 2. So 2 will cancel down. Sine will also cancel down. It will be tan t by 2. So what this becomes is simply t by 2. And what t we have is tan inverse x. So it will be half tan inverse x. Now you can go for the derivative. Yes, du upon dx will be half as it is. Derivative of tan inverse is 1 upon 1 plus x square. Similarly for v also, what v function was, that is the same, sin inverse 2x upon 1 plus x square. And we remember, this is a formula 2 tan upon 1 plus tan square. This is the formula for sine 2 theta. So better to again put x equal to tan here. It becomes 2 tan upon 1 plus tan square. That is sine inverse sine 2t. This is 2t means 2 tan inverse x. Again go for a derivative. Derivative of tan inverse is 1 upon 1 plus x square. Now du upon dv will be, this is the derivative of u with respect to x, and this is the derivative of v with respect to x. So dividing the two numbers, it will cancel down. It will be 1 by 4. So this is the way we will simply go for the derivative of parametric forms as well as the derivative of a function with respect to function. Thank you.